Hey everybody. Today our video is going to be covering the topic of principle of work and energy. Let's go ahead and get started by talking about different terms. Work done is the application of force over a distance. This is commonly expressed as FDR. For constant forces, work is defined as the force multiplied by the change in distance, or F delta R. There are many types of forces commonly observed that all follow this principle. There may be work done by the force of gravity, work done by a spring, and even work done by friction. Anytime a force is applied over a given distance, work is done. Because of this, work is related to a change in energy, both kinetic and potential energy. Let's look more closely at different applications of work.
First, the work done by gravity is defined as the negative mass times the acceleration due to gravity times the change in the vertical distance, assuming a particle starts from a higher position and falls lower. The negative sign indicates that the force is acting in the opposite direction of what is typical, aka the force is acting downwards. This makes for positive work as an object falls because the change in y is also negative. The two negative signs cancel, indicating positive work happens in a downward manner. Another common type of work is that done by a spring. Hooke's law states that the force from a spring equals the displacement of the spring from its original position multiplied by a given spring constant. Integration of this formula, F equals Ks, yields 1/2 Ks squared. This formula represents the work done by a linear elastic spring. Finally, let's look at the principle of work and energy formula. This formula states that the change in kinetic energy from position 1 to position 2 is equivalent to the net work done from position 1 to position 2. This formula can be rewritten to show that the kinetic energy of a particle at position 2 is equal to the kinetic energy at position 1 plus the change in work. This formula will be crucial in our experiment. Looking at the formula, kinetic energy is represented by the value of T, whereas the change in work is represented by the value of U.
Here is an example of work and energy. In this experiment, we place a Hot Wheels car on a slope track. The car weighs 33 grams, and the length of the track is 34 centimeters. The initial height of the car is 11.5 centimeters above the table, and the table is 83.5 centimeters height. We also measured x1 is equal to 33 centimeters and x2 equals to 36.5 centimeters. Okay, let's start the experiment. We place the car on the top of the track and the initial velocity is 0. We time the car from the initial point to the point where it leaves table, and also from table to the ground. So we could solve for the velocity at the end of the track and the final velocity. After that, we redo the experiment several times to test our measurements. This is the slow motion of the car when it moves on the track. The work done by gravity provides an initial velocity, so the car is able to move after it leaves the track. After the car leaves table, the only force on it is gravity. In this experiment, we use motion equations to solve for the velocities of car when it leaves table and hits the ground. If we assume the table is frictionless and ignore the air friction, we got Vy1 and Vy2, and apply those numbers in the work and energy equation. We find out in the unit range, the work done by weight force is equal to the change of kinetic energy.